everybody, this is going to be the first session of the first day of the ICND2 course. I think I recognize a couple of the names from last week, which is nice to just roll out of an ICND1 and right into an ICND2. I applaud you for your never-ending hunger for more knowledge. It's good to see some of you guys didn't let up at all and you're right back. I think that you'll find that the ICND2 class gets moving a bit more faster than the ICND1. And it's nice because everybody, at least if you're coming from the ICND1 last week, you'll have all those concepts fresh in your mind. This class skips over a lot of the very low-level introductions to things like LAN and WAN and these kind of loose concepts. And it's much more grittier, which I really like. So good thing that we're here. We've got lots to cover, so let's go ahead and dive in and get started. We're going to start off here immediately with troubleshooting VLAN connectivity. So as we should recall from ICND1, a VLAN is a separate broadcast domain from the rest of your network, and it could be classified as an independent LAN. Now, when we think about the LAN, at least me, myself, I'd go, okay, well, inside of this company, the local area network is everything that's local to it. And when I communicate with the internal staff, when they say LAN, we typically mean everything inside of the firewall or router at that location. Which, this is just interpretation, but, with the English language, we want to leave, not leave too much room for miscommunication. So when dealing with customers or when dealing with other engineers, if they say LAN, you might want to just make sure that you're on the same page. This is something that could be interpreted differently where this is not. A VLAN is definitely a unique broadcast domain. A VLAN will typically correspond to a separate network, or in other words, subnet. Remember, whenever we look at our host, so here's my computer, if I'm at 10.127.127.62, that IP address itself is useless without the subnet mask. The subnet mask, of course, lets me see where my network ends and begins. So if anybody else out there is on 10.127.127, they're local to me. And if they're local, it means I can do an ARP, which is a broadcast, of course, and I can ask them what their MAC address is. If they're not local to me, we'll see not locals on this side, then that's where we've got a route. I'll typically use my default gateway, and I will just ARP for his location if I don't know it already, and I'm going to have a layer 2 destination of the gateway, and the layer 3 destination, we'll just call it a far IP address, but this is going to be a remote IP, where if it's local, my layer 2 and layer 3 header are going to be the same. They're going to be targeting the same destination. Does that all make sense? Everybody with me? We can do thumbs up if it makes sense, thumbs down if it doesn't. And I'm just going to click thumbs up because, well, it's my conversation. It makes sense to me. All right. So VLANs, they say that they address these needs. Segmentation, we can separate our users. They can add to security, but they may or may not necessarily. And they lend us some flexibility. Sometimes it'll say VLANs make network management easier. Well, segmentation, we can go between different groups and say, okay, IT users are here, the HR department's there, and the sales organization is here. If I have a router, did I just gain any security? I've got 3 different broadcast domains, so I suppose there's certain attacks that may have worked before, like ARP poisoning, that aren't going to work now. But I think a lot of times what we think of in terms of securing the network, our first step many times is ACLs. So without access control lists, everyone's still going to talk to everyone. So yes, we have separate broadcast domains, but VLANs give me different subnets. That's for sure. At least 99% of the time, unless we're doing something really weird. And if I have subnets, that doesn't necessarily give me security, but it makes it much easier to perform secure operations. If I want to code an access control list and I want to prohibit the sales folks from getting into HR, well, can everyone think of an ACL that would prohibit 10.0.4.0 from getting to 10.0.3.0. That wouldn't be that hard, right? We could use an extended access list and say, hey, router, when you see packets sourced from 10.0.4.0 and they're destined to 10.0.3.0, deny those packets. So the VLANs, do they give us more security? Possibly. Depends what you're after. But they give us different subnets, which make it easier to implement security. So just one way to think about VLANs. Additionally, network flexibility. I tend to think about this in terms of network management. If I'm reviewing my log files and I see tons of failed login attempts from 10.0.4.50, I could say, okay, just looking at this IP address, off the top of my head, I'm not sure who it is, but they're definitely in the sales department. So I can look at that access list and know something about the traffic. Additionally, when I'm creating rules, maybe for browsing, right? I can say if you're coming from 10.0.3.0 at 4 o'clock in the afternoon, you can go to Facebook. If you're coming from 10.0.4.0, you cannot go to Facebook. So you could create web browsing policies later, many times using other devices such as the Iron Port or the next-gen firewall within the ASA. We can build policies based on these IP addresses because an IP block many times will correspond to a group of users. It doesn't have to, but that's many times the way that we lay out our networks. So VLANs are the basic building blocks that lead to subnets. The subnets lead us to ACLs and other policies that are based on IP addressing. So as you should know, to create a VLAN, it's pretty easy. We can step into global config, use the VLAN command. That drops us into VLAN configuration, and now we can give the VLAN a descriptive name. Additionally, if we want to start placing interfaces into those VLANs manually, we can go to interface configuration mode and just say switch port access VLAN 2. That would put the user that's plugged into FA0/2 in VLAN 2. If any of this is new to you, let me know and we can go over it in detail if you've got any questions. But a lot of this should be just review for us. We can validate that we've got our VLANs with a show VLAN statement. Show VLAN shows us the VLANs that exist and the ports that live in those VLANs. And a trunk link is an Ethernet cable. So let's just say that this is Cat5e going between two switches. Can I give ACL as a description? So do you just want a little bit more information on access control lists? Or are you saying, can you give an access list as a description? Because like a VLAN can have a description and a physical interface can have a description. Let's go over here. All right. So for instance, let's just clear this out. If I were to say VLAN 777, I could name it. This, we'll call it demo VLAN. And then I can't do a description here. But if I go into an interface, like interface gig 1015, I can do a description there. This port goes to Mary. Not a very good description. And then I could simply say switch port access VLAN 777. And we're done. So a trunk link would be the opposite of an access port. An access port is intended to be many times a single cable drop that goes to somebody's cubicle and they're going to plug in their computer on the other side of it. The trunk link is the link between two switches that carries all the VLANs. So for example, if I've got VLANs 10, 20, and 30 configured on the left, 10, 20, and 30 on the right, each of these ports is in one VLAN only. VLAN 30, VLAN 20, VLAN 10. A trunk port is in all VLANs, and it can carry all VLANs across that wire without cross-contaminating any of the traffic. And the way that it does it is it takes that Ethernet frame and it gives it a special tag. And it says this is for VLAN 10. This Ethernet frame comes in and we go, this is for VLAN 20. And here's our Ethernet frame over here for VLAN 30. We just add a little label here for 30. And as those frames traverse this link, they're going to include what's called an 802.1q tag. Any questions on that so far? The tag is just an extra field on the Ethernet header that says what broadcast domain these frames belong in. If you plug in two switches together that are Cisco switches, they speak a protocol called DTP, Dynamic Trunking Protocol. They'll learn that, hey, that's a Cisco switch on the other end, and they'll automatically transition to a trunk interface. So a trunk is just a link that carries multiple VLANs. Everybody all right with that? All right, I appreciate the feedback. And if not, just throw questions into the room chat and we'll cross them as we come to them. Now, where do trunks exist? More places than you would imagine. So let's say that we've got two switches here, and we took ports 23 and 24 off of each of these switches, and we plugged them together like this. These would be trunk links, and we've got two of them there so that we have some redundancy. We know spanning tree will break the loop that we just created, so not much to worry about. So these are examples of where we would find trunk links from one switch to another. But we don't only have wired access, right? Does everyone have a wireless network? I'd assume so. If you don't, just let me know in room chat, say no wireless. But I assume everybody has a wireless network, right? This isn't a class on wireless, and we don't really get into it within ICND2, but you can appreciate that if I run this wire to a wireless access point, this wireless access point could have multiple SSIDs. Have you ever been to a hotel before, and maybe it says Marriott, and it says Marriott guest? So we've got two SSIDs, or two service set identifiers, and you can tell your laptop which one to join, right? You can say Marriott or Marriott guest. If you come to Marriott, it has WPA2 in enterprise mode, meaning you have to have a username and password to log into this network. It's going to encrypt everything with AES, and it's going to put you, when you're done, into VLAN 25. However, if you connect to Marriott Guest, this is open. There's no authentication required. They're going to push you through to a captive portal where you'll have to say, I agree to a user policy to use their internet. And here, this is going to put you into VLAN 50. So what we just learned is that a single access point can support multiple service set identifiers. And then when a user connects to a particular SSID, it defines the type of authentication to join the network, and then it'll typically put you into different VLANs. So what we learned is that your access point may very well have a trunk link going to it, and this allows us to support VLANs within the wireless network through different SSIDs. Now that's nothing that you'll have to know for the ICND2 exam. They're not going to expect you to know wireless, but we are network engineers, and there's wireless all around us, so we should just be aware that sometimes we're going to need to trunk to an access point, and this is why. Now, how many of you have used VMware before? Thumbs up if you have, thumbs down if you haven't. All right, so we've got a mixture of about 50-50. So quick crash course on what happens with VMware. Got another wire. This time I'm going to go to a server. And my server has got VMware. It could be your hypervisor of choice. It could be KVM. It could be Hyper-V. I tend to use VMware a lot. And this is going to have what they call a hypervisor. Type 1 hypervisor. The operating system we put directly on this server is ESX. It was a 5-minute install. It was very, very simple. And now this physical server is willing and ready and able to host virtual machines. So I create these virtual machines. Let's use some different colors. I've got one here for SharePoint. I've got another one here for an Active Directory domain controller. I've got another one here that's being used for a database. and I have another one that is, let's say, the ICE server. This is the Identity Services Engine from Cisco. Each one of those colored boxes is a different virtual machine. And your virtual machines can reside on different networks. So what ESX, which is from VMware, and what all the other vendors do as well, is they provide virtual switches. So what's going to go right in here is called a vSwitch. So this SharePoint server could be in VLAN 10. My Identity Services Engine could be in VLAN 20. My database could be in VLAN 30. And Active Directory could be in VLAN 40. And then once again, this link, which connects to this server, would be a trunk link. Everybody with me so far? So it's not just for connections between switches. Anytime we want to connect to a device, like a wireless access point or a server that supports different VLANs, you could have a trunk link. In my environment, I've got an ASA over here. And that's Cisco's firewall. Whenever you come in as a VPN user, depending on what it is that you're trying to gain access to, different users authenticate and they belong to different groups. Well, since they're joining the network, when they come in through this firewall, different groups correspond to a VLAN. So if you're a student and you were to connect to talk to my lab hardware, you might go into VLAN 29. And if you are me or my spouse, you might go into, so we'll say if you're a Linfield, you might go into a different VLAN. So based on your authentication, you're going to get applied to or assigned to a different VLAN. And based on that VLAN, you're going to get an IP address. And you're going to get an access list that defines what you're allowed to communicate with. So once again, I've got a trunk link here that goes to my ASA because I have people joining my network. They're coming in across the internet and hitting this firewall, and there's different groups of users. Just like you might have different groups of users that are physically cabled or connecting through wireless or living in virtual machines. So trunk links would connect to any device that's bringing in different resources that belong into different subnets. You guys feel pretty comfortable with that? You don't have to know firewalls, access points, or virtualization. You just have to say, okay, sometimes my switch ports are going to be set to being a trunk port, even if it's not going to a switch. It's just a device that's got users in different VLANs, and they need support for trunk links to talk to those different VLANs. All right, good. So that's trunk operation. How hard is it to configure a trunk? We say switch port mode trunk opposed to switch port mode access. How does that affect you in like a day-to-day basis though? Well, if I had two Cisco switches and I connect these switches together, they automatically form a trunk. You didn't have to do anything. By default, unless you turn it off, they're sending those DTP messages and the trunk process was automatically negotiated. Well, some people don't like automatic negotiation. They say it has a chance to fail, so they think it makes more sense to hard code it as a trunk link. You could do that as well just by saying switch port mode trunk. Now, what they're not showing us here is setting the encapsulation. So let's talk about that for a second. If I were to take this class and go, okay, they say this is how I configure a trunk link, let me leave Ryan's class, let me go back to my production switch, and I'm going to clear the configuration on my lucky interface, which is 15, and we go back into interface gig 1015, and I say, okay, based on what I learned in class today, they say switch port mode trunk, and optionally, I can change the native VLAN. We're going to talk about what a native VLAN is in a second. What we want to do for now is just set a trunk link. Let's say that that port is going to go to a server, and I'm going to set up some virtual machines. So just like it says, I'm going to say switch port mode trunk, and it doesn't work. Raymond says I've got to set it to .1Q first, and he's right. This is an interface whose trunk encapsulation is set to auto, cannot be configured to trunk mode. What on earth are they talking about? Well, Cisco by default is running DTP, which is that dynamic trunking protocol. So he's messaging the other side saying, hey, do you want to become a trunk? If so, totally, let's do this trunk thing. It's going to be awesome. Let's go. Well, what he does is, this is kind of ironic, but it uses an encapsulation method called ISL. Now, let's go back to what we learned in ICND 1. We have data, which we like to lump together and just call payload. And this is everything that's happening at layers 5 through 7 of the OSI model. You and I are not really concerned with that at this point. We're concerned with layers 4 through 1. If that works, our job is done. If it doesn't work, we've got some work to do. At layer 4, a lot of times we might have TCP or UDP. At layer 3, we've got IP version 4. At layer 2, a lot of times we've got Ethernet. And at layer 1, you could have wired or wireless, fiber or copper, etc. Now, when we talk about encapsulation, that's just putting the payload inside of a TCP header inside of an IP header inside of an Ethernet header. These guys are just envelopes, right? So when we encapsulate, you can encapsulate using what's called 802.1q or ISL. These are different encapsulation methods. Both of them allow us to set what we describe as the VLAN tag. This is just an indicator that says this Ethernet frame belongs in VLAN 25. There's two ways to do it. One is called ISL, one is called .1q. Everyone with me so far? There's just two ways to mark this. ISL is very, very, very old, and I'm surprised that modern switches still support it. Cisco used to recommend that you use ISL. This was their proprietary format, and they said you should use ISL, it's the best, we created it. But you have to remember, Cisco gets a lot of its products through acquisitions. They acquire other companies, put a Cisco logo on the front of it, and they say, here, buy these phones. Well, when they do that, guess what the acquired technologies don't do? They don't run Cisco proprietary technology. So Cisco for years said ISL is the default, ISL is the best, you should use ISL. Then they acquired a phone company. Not in the sense of like a carrier like Verizon, but someone who makes handsets. When they did this, those phones only did .1q. Cisco changed their tone immediately, and they said, you should totally use .1q. What were you doing with ISL over there? So you'll find that .1q is wildly more popular. When you connect to VMware or Hyper-V or KVM as a hypervisor, they support .1q. When you connect to your access points, they support .1q. When you connect to Cisco Nexus equipment for data center switches, .1q only. When you connect to a Cisco firewall, .1q only. ISL is pretty rare, but here's the messed up part. If you have two switches that auto-negotiate a trunk, like a pair of 3750s, they actually default to ISL, which is super freaking weird. Doesn't make any sense to me, but just how it works. What we can do as network administrators is we can come over here, and instead of allowing it to automatically negotiate ISL, we say get rid of that stuff. We want to do switch port trunk encapsulation, and here you see we can do ISL, we can use .1q, or we can allow it to negotiate. Negotiate is what it does by default, but what we probably want is .1q. This shuts off the negotiation, which is why it was complaining here. You can't be in the negotiate or auto state if you want to hard code it to be a trunk. We would then come along and say switch port mode trunk. At that point, you're now in good shape to communicate with a device that's trying to do VLANs, whether it's an access point, a firewall, a server, a router, or anything else that's going to be doing .1q. So far, so good? And I keep asking that because that's what I ask before I turn the page and go a little bit deeper. Just want to make sure everybody's on board. Good deal. So come back over here. Like this slide is saying that this is how you configure a trunk port, but it's not really. This would work on like a 2950 or 2960 because certain switches don't support ISL anymore, but some do. The switch that I was just configuring was a 3750X, which is a pretty nice switch, and it does ISL. So on most hardware you come across, you'll have to precede this command by saying switch port trunk encapsulation .1Q. And just to show you again, this is that command. It says I want to be, when we're trunking, I want the encapsulation to be .1Q. And now we say, let's go ahead and force trunking on this link. So what happens when you become a trunk? Well, by default, you're going to carry all VLANs over that link. You can support anything, and whatever packets show up might show up. One of the things that a trunk link does, and this is because they invented this a long time ago, is it has a concept called a native VLAN. So let's say that I've got a switch over here with VLANs 10, 20, 30, and 40. Quick question for you. Did I forget a VLAN? Is there another VLAN on that switch that I forgot to write down? VLAN 1. Good job, guys. Every switch has VLAN 1 by default, and VLAN 1 is the native VLAN on a trunk link. So the concept of this slide is native VLAN. Native VLAN has some other terms or names. Sometimes it's described as PVID, which is the port's VLAN ID. Sometimes it's called the untagged VLAN. Sometimes it's called the default VLAN. So what are they actually saying here? Well, between these two switches, we've got one link. What happens if some Muppet were to come along and install a hub between our two switches? Would it still pass frames? Certainly. But it would turn our full duplex communication into half duplex. The performance would drop, we'd start having collisions, but it would work. And what happens if that same guy or gal was to add a PC here? Well, the PC doesn't know anything about tagging, so he just sends regular old Ethernet frames. I'm going to say regular Ethernet onto the network. And what does the hub do with those regular Ethernet frames? Well, anything that comes in one port gets blasted out all the other ports. So if a switch, by some chance, like in this scenario, is to receive a frame, it's an Ethernet frame, a layer 2 datagram, with no tag, where on earth does it go? And that's what the native VLAN describes. That's why they sometimes call this the default VLAN, or the untagged VLAN, or the port's VLAN ID. Does that all make sense? And like Eric is saying there, that frame that comes from this PC that's plugged into the hub is going to land in the default VLAN. Is everybody 100% on that, or do you have any questions at all? Eric says 100%. All right, good job. So let's see what actually happens. Are you going to have anybody plug a hub in the middle? I hope not. So on a typical network, what's going on with that native VLAN? Well, once again, here's switch A. On the right, we've got switch B. Here's our wire between them. Whenever a host that's in VLAN 1 sends an Ethernet frame, it comes in with no tag. It comes across this link with no tag because VLAN 1 is a native VLAN. So if a switch has a frame that's for VLAN 1, he doesn't add a tag. And then when it goes out to talk to the server, once again, there's no tag. However, if you're in VLAN 20, well, you don't send an Ethernet. When you send out your Ethernet frames from your PC or laptop or IP camera or whatever the device there is, there's no tag there. But when you cross the trunk link, the switch knows that this frame needs to be isolated from others. So he's tagged for VLAN 20. It's going to come across this link, and it lets the receiving switch go, oh, this frame goes into VLAN 20. When he sends it out this port, again, assuming this is just an access port going to some other user that's in VLAN 20, there will be no tag here. So in summary, whenever we look at a trunk link, all VLANs are tagged except for native. Any questions with that as a concept? This is something folks show up in more advanced classes. You know, we come across native VLANs, and this is where I start to see some kind of confusion in people's eyes or in questions when they're asking, because not everyone understands this. So the native VLAN is just the VLAN that we're not going to tag data for. That's it. So I don't see any questions coming in. So I'm going to pretend there's a question from, we'll make him an imaginary student called Mary. And Mary says, why do I care? If one VLAN gets tagged, why on earth do I care? And I go, well, it normally doesn't matter. What we want to think about is it the same on both sides? Because it needs to be. We need to make it match. And they go, well, in my environment, every time that we set up a trunk link, we're always supposed to do switch port trunk native VLAN 99. And they say what we do is we always change our native VLAN to be something other than 1. And I go, that's okay. You can do that if you want. Just make sure that there's a rhyme and a reason to it. Why are we changing it to something other than VLAN 1? And what happens is whenever you plug into a port that hasn't been configured, this is VLAN 1. Your default VLAN, everything goes into VLAN 1 by default. I think that's a pretty good model. Every Cisco device that I ever plug in, you know, if I add a switch today and I plug a device into it, or if one of my existing switches loses its config, this is where everybody lands by default. If I approach my network as such, no big deal. If you put really important things in VLAN 1 that should not be accessed, then by all means, change this to something other than VLAN 1 to make sure that people don't wind up there by default. Don't change your native VLAN just for the sake of changing it. Change it because you have some purpose. A good purpose is, well, my predecessor decided to use VLAN 1 as the management VLAN for some reason. I've inherited this environment, and I want to make sure that nobody lands in VLAN 1 by default. So I come to each of my trunk links and I say, you know, switch port trunk, native VLAN, some other VLAN. Does that make sense? In recap, I always leave this as VLAN 1. What's the default VLAN that some user would plug into if I added a hub? I would never add a hub. But if they did, for some reason, they're going to go into VLAN 1. What's in VLAN 1? Nothing important. If it is important, you could change it to be something other than VLAN 1. Is the native VLAN assigned on a trunk-to-trunk basis? Absolutely. You could make this different on every single trunk link. If I was your coworker and you did that, you probably wouldn't be my favorite person, but you definitely could configure it differently on every single trunk link. It just means that that VLAN gets no tag. So once again, coming back to my pretend student Mary's question, and she's going, why do I really care? Well, let me show you something. If we were to look at a VLAN tag, let's just bring up Google and say VLAN tag, 802.1q tag. If we look at this, what we're adding, come on, Google Images. If you look at your layer 2 frame, you're adding this tag. Let's see if we can find a better image. This is a little bigger. So here's your destination MAC address, your source MAC address, your ether type, your payload. This is your layer 3, layer 4. Everything layer 3 through 7 is where it says data. And then you have a frame check sequence to make sure it's not corrupt. When we tag a frame, they're talking about these 4 bits. I'm sorry, these 4 bytes. These 4 bytes were not there before. We inserted this into the Ethernet header to give it a marking. This marking has not only the VLAN ID, but it also has a priority field. Anybody want to take a guess at what this priority is used for? And it's just like your boarding order on Southwest or Delta or anything else. Absolutely, guys, it's for quality of service. So you can do QoS at layer 2 or layer 3. You don't have to know QoS for ICND2. But as a network engineer, you should be quality of service. Basically just means not all packets are equal. So what you do is packets that are sent, and I guess I should say frames because we're saying layer 2 here, right? I'll say every single frame that leaves my Cisco voice over IP phone has an Ethernet tag on it, right? So when my phone sends frames out, they're tagged with the voice VLAN. Not only does it tell the receiving device, my switch, that this frame goes in the voice VLAN, but it also gives me a field to set quality of service at layer 2. So that's important. When you think about your trunk links, let's jump back over here. When we look at that trunk link and someone says, I'm going to change my native VLAN to be something else, I'd say, okay, kudos for you. Have a good time with it. Just remember, make sure this is not your voice VLAN. Why do I say make sure that it's not your voice VLAN? That's the native VLAN. It's untagged, and if it's untagged, you don't have that priority field. So from a layer 2 perspective, every single Ethernet frame is the same. There's no quality of service in the Ethernet header. If you want QoS at layer 2, you've got to have a VLAN tag. Layer 3, it's built in. We've got a priority field, but at layer 2, we don't. So this isn't something that you have to think about. You're not really thinking about voice over IP and ICND1. You're not really thinking about QoS. But what we can appreciate is that if you have no tag, you have no quality of service on those frames. There's no way to say they're better than or worse than other data. If you do have a tag, you can. So this isn't something that they would normally tell you in ICND2, but it's easy enough to appreciate, right? When you pick a native VLAN, just make sure it's not something super important that you're doing traffic engineering for elsewhere in your environment. Cool. So this is how we configure a trunk. We saw that our trunk configuration was a little different. Depending on the switch that you have, you may have to say switch port trunk ncap.1q first. This is an optional command. I always leave it as VLAN 1. I didn't write iOS. I'm not John Chambers. I'm not, I'm just another network engineer. But I tend to not change that unless I have a good reason to do so. Should really have a good reason. Because if you change it to something else, you've got to make sure that it's changed on the other end. And I hear people go, well, it's not a big deal. I control both switches. And I go, no. You're connecting your switch to firewalls, and you're connecting your switch to routers and wireless access points and to servers. And when you start talking to the guy who runs these servers, do you want to have a discussion with him about what native VLANs are? I like talking to the server guy, but I normally like to learn things. I want to hear from him what's going on with, Active Directory, or what's going on with, Windows 8.1, or what's going on, what are the new Windows features that I don't know about? I normally don't want to have to describe to him native VLANs and tell to him to configure his server interface so that a certain VLAN is untagged. I'll just leave it as 1 and not think about it any further. Make sense? And then I tell the server admin when he sets up his server interface to always make sure that it's tagged. Whatever he's going to manage on, I say always make sure that it's tagged. And then he can give his management traffic QoS characteristics. In other words, if I've got an IP-based keyboard, video, and mouse, IPKVM, in Dell, they call that DRAC. In HP, they call it ILO. On Cisco's UCS servers, they call it CIMC. This is how I manage the server, right? If I'm installing a hypervisor, there will be what they call a VM kernel interface. This is how I run the server, and then there's user traffic. Well, if we're totally congested, I might want to say that that management traffic is more important than other types of traffic. I can't do that if I don't have a VLAN tag. So I try to have everything important tagged and not put anything important in VLAN 1. That's just been my recipe. So it is completely optional to change this. Just make sure whatever you change it to is not important. And make sure it's the same on both sides. Cool. So that's trunk links, that's native VLANs. When you look at an interface, you can do a show interface, and you can do show interface with a switch port at the end. If you were in IC&D with me last week, I beat this to death, but I'm sure not everybody was. So let's take a look at it. If I say show interface gig 1015, it's going to show me things like the interface state is down and down. It's going to show me the MTU, the bandwidth. It's going to show me all my interface counters. If I use the up arrow and I grab that same command and I put the word switch port after it, now it's going to show me different output. This is going to show me configuration parameters. No counters, but it shows me things like administratively this is set to a trunk port. It's enabled. And I'm doing .1q encapsulation. If I'm working as an access port, I'd be in VLAN 1, but when I'm working as a trunk port, my trunk native VLAN is VLAN 99. Cool? So we can validate that .1q is in use, and we can see our native VLAN. Additionally, if you do a show interface trunk, this shows you the status of your trunk ports. So in my case, if I come over here and do show interface trunk, show interface, we should do gig 1023 trunk. We can see a bit more, right? We see 1023 is hard-coded to be a trunk port. It's on. It's using .1q encapsulation. These are the VLANs allowed, 1 through 4094. And these are the ones that are currently being forwarded. Pretty cool. So Cisco, by default, allows all VLANs on a trunk link. What I've seen some customers do is go into that trunk link. So go back to my physical interface and say switch port trunk allowed VLAN, and then they put a list here. So they'll say VLAN 5. At that point, only VLAN 5 is allowed. No other VLANs would be allowed to cross that one wire. Let's see, coming back to the room chat. The native VLAN needs to be the same on each side of the trunk. Correct, Reggie. And Eric says you have a native VLAN mismatch if they're not. Correct. So what happens is pretty nasty. You'd have, here's my switch, and I say on this side, native VLAN 10. And on the other side, I say native VLAN 20. If I were to do that between these two switches, it would be pretty crazy, because if this device was supposed to be in VLAN 20, and this device is supposed to be in VLAN 10, and then over here, let's say in 20, I have a DHCP server, what's going to happen when this comes across from VLAN 10, if he sends out DHCP, that's a broadcast. Well, it's going to come in, it goes out of here, untagged. Over here, VLAN 20 is untagged. So he's going to get assigned an IP address from VLAN 20. Does that make sense? So you could have users that are winding up in the wrong VLANs. Now, additionally, CDP is going to tell you that there's a mismatch. He's going to spam your console and let you know that it's misconfigured. That's between two Cisco switches. But if this is Cisco and this is brand X, whoever it might be, doesn't do CDP typically. Now, I've showed you, if you guys have been with me in other classes before, I've showed you some funny stuff, right? Like I've come over here and I've said show CDP neighbors. And I showed you that these are actually HP access points. There's a wireless, I'm sorry, those are Cisco phones, but this is an HP access point and this is an HP wireless LAN controller. So there are other devices that aren't actually HP, that aren't Cisco that do CDP. If I come over here and I say show CDP neighbors, one of the devices that shows up as a CDP neighbor is a Dell 10 gig Ethernet switch. So other devices will do CDP, which kind of is goofy. You're like, wait, you're not Cisco, but okay, I appreciate the help. But while they'll do a CDP advertisement, they may not notify you that there's a mismatch. Cisco on Cisco will tell you there's a native VLAN mismatch. I'm not sure what happens when you start getting into Dell and HP and other guys that are kind of doing this like pseudo CDP across. I'm not sure if their messages include that native VLAN. How do you know? Well, you could look at Wireshark. Wireshark would actually tell you that. Yeah, let's look, just because we're talking about it. And it's been almost 50 minutes without Wireshark. We don't want that. You guys like Wireshark, right? Or you guys like, no, like, don't get Ryan on these Wireshark tangents. He forgets about the slides. All right, we got clapping and thumbs up. So we're going to do some fishing here. We got to wait for CDP, and it's like staring at the bobber, waiting for it to move. CDP goes out every 60 seconds, and it's got a hello. Hello is 60 seconds. Your dead interval is 180. So if you miss 3 CDP hellos, you assume that your neighbor's gone. So, man, it feels like an eternity that we've been staring here. What I hope will happen, and sometimes live demos don't always go the way that I want, we should see a CDP message come up, and I'm hoping we can open up that CDP message, look inside of it, and have it tell us what the native VLAN is in a TLV, or type length value field. Man, I was sweating there. So here we see a layer 2 Ethernet header. Source is a Cisco device. This is a special destination MAC address. See that 01000 followed by all C's? This is a special MAC address, and when frames are sent here, this is for Cisco devices. This is used by CDP, VTP, DTP, PAGP, which is your port aggregation protocol, and unidirectional link detection. So this destination MAC address is used for a lot of Cisco services. When we open up the CDP message, we can see here, they're sent about every 60 seconds. The time to live is not in hops. Look at that TTL. It's 180 seconds. That's how long this message should be stored for. We see here the device ID, the software version, the address, the port ID capabilities. Here we go. The native VLAN is 127. There's an actual field in a CDP message that tells us that. Pretty cool, right? So we can see native VLAN in that message. So that's what the Cisco devices are showing one another, and when they see a mismatch, they actually alert you at the console, because we don't want that mismatch, of course. All right. DTP is Dynamic Trunking Protocol. This is the magic and the secret sauce that makes Cisco so easy. If I take 2 brand new switches out of the box and I cable those switches together, voila, DTP and CDP are running by default. They're going to discover, hey, you're a Cisco switch, I'm a Cisco switch. Let's set this up as a trunk. Let's carry all VLANs and let's make everything work automatically to make the user's life really easy. That's what it does. manual configuration is recommended just so that you're not magically forming trunks with anybody who wants to. This is easy, but easy is never good for security. If I bring out my little hacking laptop and I were to plug this in, I can send DTP messages, which means my evil laptop here now has a trunk link, and we're now a member of every VLAN. Does that make sense? If a Cisco device can send CDP and DTP, so can my Linux box. So I can form a trunk, and now I can be on every VLAN. So it's a blessing and a curse. They say for your users, we should not allow those to be dynamic ports. Every port is a dynamic port by default. This is where we are, which says if you talk to somebody else who's dynamic auto, like a Linux box running your Xenia, you could go ahead and negotiate a trunk port. You could say, I want to become a trunk. And the other guy will go, well, OK, let's go ahead and do some trunk stuff. And you're now members of every VLAN. What they suggest that you do is set access ports to access. That's what's going to your users, and then trunk ports to trunk. So manually configure everything so that you can't have malicious people mess with you, and you can't have anything fail to negotiate. To check our VLANs, we can do show VLAN. When you do show MAC address, what's kind of cool is you'll see MAC addresses being learned on a VLAN by VLAN basis. So if we pop over here and we say show MAC address table, it says VLAN all. These are for the static burned-in addresses. Remember we saw messages destined for 0100, 0CCCCCC? Every Cisco device has this. If I come over here to that's my 3560. If I look at this 3750X, show MAC address table, once again, he's like 0100, 0CCCCC, that's me. Same thing with this one. These are reserved by Cisco. The rest of these are burnt into the switch. And then you start seeing MAC addresses being learned on a VLAN by VLAN basis. So here's VLAN 127. Here's the MAC address. It was learned dynamically on that interface. Same thing on my 3560. As I scroll down, these are in VLAN 75. These guys are in VLAN 10. These guys are in VLAN 50, VLAN 128, VLAN 249. You get the idea. So different MAC addresses are learned to exist in different VLANs. Cool. So show VLANs. Another thing to check is our interfaces. Another thing to check is our switch ports. Let me show you one last thing, and we'll be ready for a break. We talked a lot about trunking. When you set up that trunk port, so let's do show run interface gig 1015. See where we're at. We said switch port trunk encapsulation .1q. Switch port trunk native VLAN, we changed it from 1 to 99. But I put a restriction on what VLANs are allowed. I see a lot of customers do this, and you have to be careful with this. Cisco by default allows all VLANs on a trunk link. You can prohibit that with this command. So if you had users in VLAN 5, they can communicate across the trunk link. What if I've got 2 users on 2 switches in VLAN 10? Are they going to be able to ping each other? Gavin says no, and he's correct, because we're only allowing VLAN 5 across the link. So here's what happens. You go to modify it. We go, OK, we got to add VLAN 10, right? So we say gig interface 1015, and I say switch port trunk allowed VLAN 10. Now I say do show run int gig 1015, and watch what happens. 5 just got removed. And Eric said add several times. Do you see why he said that? You might come into an environment that says VLAN add 10. VLAN, and you could put it in here as a list as well. So let's do our show run command again. See, now it says switch port trunk allowed VLANs 10, 20, 30, 40. This is what I've seen customers do and cause big outages on accident. They come in here to add 50 without saying add. They say switch port trunk allowed VLAN 50, thinking it's going to add it to the list, it blows away everything, as I showed you before. So now all the traffic for VLANs 10, 20, 30, and 40 just got dropped. And everybody's starting to look around their cubicles and go, hey, did you just lose your phone call? Yep. As Eric's saying, triple check that you've got the word add there. If you do it without the add, you're going to drop everything. And I've been teaching for about 10 years. I've come across a ton of people, and I've done it myself. I've just slipped and didn't put add, and you drop all other VLANs. So this is a situation where I personally prefer to not do this. So I can show run interface gig 1015. And for me, I'll just send all VLANs across that trunk link and never have an issue. But sometimes you'll want to do it. So watch this. For example, I could have a switch connected to another switch. And these users have got 1 gig. You know what? Let's say that these are servers, and we'll make it a little fancier. They've got 10 gigabit per second NICs, and they're doing iSCSI in addition to regular IP data traffic. What I might do is I might dedicate one of my uplinks to be iSCSI only. And iSCSI is just an alternative to Fiber Channel. I can have that server, and when he mounts a disk, his disk is in an array over here. So when he talks to his D drive is like 6 disks across 3 different arrays. And that's all, basically hidden from him. It's almost like NAT. You've got a storage processor, and he connects to this as an iSCSI target, and that just breaks up all his disk on the back end. But if you think about it, every time he reads or writes from the hard drive, it's going through our switches. So I can have a dedicated trunk link just for iSCSI and a dedicated trunk link for my regular IP traffic. Does that make sense? If I'm doing something like this, that's where I get into allowing certain VLANs on a certain trunk link. Or if I've got somebody who's got a mission critical application that's, really, really bandwidth hungry, I'll put that particular application on an individual wire or set of wires. If I want to perform traffic engineering, I might break up which VLANs are allowed on a trunk link. But I normally don't do it just for the heck of it. It's going to depend on your environment. You're going to have senior network engineers or a vendor that'll come in and they'll have a methodology. They'll say, we designed our network and we only allow these VLANs for this reason. And it might make a lot of sense. Every environment's different and everyone who creates a network has different strategies. But for me, when I do switch port trunk allowed, I'm doing it for a reason. I'm doing it because I only want that particular type of traffic on that wire or that pair of wires. Make sense? Your environment might have something different. So there's not, one solution that fits everybody. Super cool. All right, so that gives us about 1 hour into this. Let's see, show MAC address table. We saw how we can look at different interfaces. We saw how we can do show interface switch port and see the configuration of the interface, not just the counters. And with trunking, things to watch for, native VLAN mismatch, but it'll normally tell you. And just make sure that you have the encapsulation set to .1Q on both sides. ISL is very much legacy. I haven't used it in production. I caught myself. I say I never use it in production, but guess what? If these two switches dynamically negotiated their link, many models that are still current will actually use ISL. I find that alarming because you wouldn't want it, but that's what it will default to. So ISL is what you're going to get if DTP sets up your trunk port for you. What you want to use is .1Q. So switch port trunk encapsulation, .1Q, and switch port mode trunk on your trunk links. All right, so that wrapped up VLANs and trunking, and we're off to a really good start for day one. We'll say day one, session one. Is that pretty good? We didn't talk about what is a LAN, what is a WAN, what is a network. We just jumped in there. We started looking at frames. All right, maybe I'm the only one having fun. I don't see any thumbs up. So I might be alone on this one. This is a tough audience. I'd tell you guys a joke about UDP, but I'm not sure that you'd get it. So, see, you like that? You like that? We'll go ahead and do our break, and I will see you guys back in 15 minutes.